Hello everyone, my name is Ishtar Tabasu. In this video, let's learn how to implement a PL LED Blinky demo on the OSDZU3-REF Development Platform by leveraging Vivado and Vitis tutorials on Octavo Systems website. First, let's start with Vivado and put together a simple hardware platform for the PL LED Blinky demo. The steps for the Vivado tutorial can be broadly categorized as follows. Install board definition files, create block design, validate block design, generate HDL wrapper, generate bit file, export hardware platform. Let's go to octavosystems.com. Under products, go to OSDZU3-REF product page. Under application notes, click on OSDZU3 Vivado tutorial. All the steps we'll be following in this video are directly pulled from this tutorial. As part of tutorial requirements, download and install the version of Vivado recommended under section 2.1 of the Vivado tutorial. Today, I'll be using version 2021.2. The download requires Xilinx login and installation takes about an hour. To save time, I've already installed Vivado on my system. Next, download the board definition files using the given link under section 2.1. It is provided as a zip file. Unzip the file once you download it so that it becomes easier to use it later. For this video, we won't be needing OSDZU3 Helper TCL file because the required GPIO constraints for the PL LED demo have already been included in the OSDZU3-REF board definition files. OSDZU3 Helper TCL file becomes necessary when creating a custom board and when custom or new GPIO constraints need to be added. Next, create a Vivado Workspace directory. I'll create a directory named Vivado_Workspace under my home directory. Launch a new terminal from your Vivado Workspace directory. Open Vivado by sourcing settings.sh from your Vivado installation directory and then use Vivado command. In my case, it is source, tools, Xilinx Vivado 2021.2, settings 64.sh, and then the Vivado command. Let's install the board definition files using method 2 as described in section 3.2. Select Tools and then Settings. In the Settings window, click on the little arrow next to Vivado's Store option to open a drop-down. Select the Board Repository option. Add the path to the OSDZU3-REF BDF directory we downloaded and unzipped in the previous step. Press Apply and then press OK. Next, let's create a hardware platform project. Click on File, select Project, and then select New. Under New Project dialog, click Next. Set the project name as PL LED Blinky and click Next. Set project type to RTL project and check the Do Not Specify Sources at this time box. Click Next to continue. In the Default Part dialog box, search for OSDZU3 under Boards. Select Octavo OSDZU3 Reference Design and then hit Next. Verify the board name and part number under New Project Summary and click Finish to create a new project. Now, it's time to create a block design for PL LED Blinky. The first step is to add the Zynq UltraScale Plus MPSoC IP core to the design. To do so, click on Create Block Design under Project Manager. Set OSDZU3-REF_PL_LED as design name and click OK. Under the blank design canvas, right-click and select Add IP option. Type Zynq in the search box and then double-click on Zynq UltraScale Plus MPSoC. The Zynq UltraScale Plus IP will be added to the block design. The Zynq device is not yet configured for the chosen OSDZU3-REF BDF. Click on Block Automation option to configure the Zynq UltraScale Plus IP with the BDF settings. When the Run Block Automation dialog box appears, check All Automation checkbox and Apply Board Presets checkbox. Click OK to finish configuring the IP. The Zynq UltraScale Plus IP is now configured to work for the OSDZU3-REF Development Platform. Next, let's add the PL LEDs to the block design. This can be done in two ways. The first way is to use the PL LED constraints already defined in the OSDZU3-REF board definition file. The second is to manually add custom GPIO constraints that map output pins of the Zynq UltraScale Plus MPSoC to the physical LEDs on the OSDZU3-REF without using a BDF. Manually adding custom constraints only becomes necessary when a BDF is not readily available for a custom board. The Vivado tutorial demonstrates both options for adding user I/O. The tutorial uses BDF GPIO constraints for adding push buttons and DIP switches on the block design. The tutorial also shows how to add custom constraints to add PL LEDs to the block design. For this video, since we already imported OSDZU3-REF BDF, we can use PL LED constraints directly from it. The process is similar to that of push buttons and dip switches already captured in the Vivado tutorial. To add PL LEDs directly from the OSDZU3-REF BDF, click on the Board tab under Block Design window. Under General Purpose Input or Output, double-click on 8 user LEDs. Under Connect Board Component window, select GPIO and click OK. This will add the PL Axis GPIO core to the block design. In the block design canvas, run connection automation. Check All Automation option, leave other settings in their default state and click OK to properly connect the new Axis GPIO IP to the block design. If necessary, you can clean up the block design connections by right-clicking on an empty space in the block design canvas and choosing Regenerate Layout option. Now, let's move on to validating the block design. Under Tools, select Validate Design. Ensure Validation Successful dialog box appears to confirm successful validation. Now, let's create HDL Wrapper. Click on the Sources tab. Under Design Sources, right-click on the OSDZU3-REF PL LED.bd file and select Create HDL Wrapper option. In the Create HDL Wrapper dialog box, select Let Vivado Manage Wrapper and Auto Update checkbox. This will create a top-level HDL wrapper file for the design. Since we have added PL LEDs directly from the OSDZU3-REF platform's BDF, it's not necessary to add custom GPIO constraints, and we can move on to generating a bit file. To do so, click on Generate Bitstream under Project Manager. Vivado will bring up a prompt asking if it is okay to launch synthesis and implementation. Click Yes. Under Launch Runs window, you can leave the default settings as is and click OK. The Generate Bitstream progress bar will appear, and this process can take several minutes depending on the performance of your computer. Once the bitstream generation process finishes, Vivado will bring up the Bitstream Generation Completed dialog box. Click OK. Vivado will open and display implemented design on the FPGA fabric. Finally, it is time to export our PL LED Blinky hardware platform so that we can later import it to Vitis and build PL LED Blink software application on top of it. With the implemented design open in Vivado GUI, select File, select Export, and then click on Export Hardware. The Export Hardware platform window will open. Click Next. Under Output, choose Include Bitstream option. Click Next. Set XSA file name as OSDZU3-REF-PL-LED-HW for hardware. Click Finish. The Vivado hardware platform file with a .xsa extension should now be exported and available in your Vivado project directory. Now that we have successfully generated a .xsa hardware platform file, we can move on to Vitus tutorial and use the instructions given to import the hardware file and build the PL LED Blinky software application on top of it.